Okay, let's look at our last set-related function. So given our commonly known sets A and B, if we get a function from A to B defined by this set of ordered pairs, or pair, is it a function? So how are we going to check this? We need to make sure that it fits these three underlined things. Well, firstly, is it a subset of the Cartesian product? And the answer is yes. Every element on the left appears in our domain A, and every element on the right appears in our codomain B. So it's true. Second element, every single element in A is being mapped onto something in B. Well, that means that we have to have all four of these elements appear in our function. And what do we see? Well, that's obviously not true because we don't have 2 or 3 or 4. We only have a 1. So where is 2, 3, or I guess the word would be and 4? What if x is equal to 2 or 3? Right, like this is what you should be asking. Well, what if I make x equal to 2 or 3? It's not mapped onto something in our codomain. So it breaks our second underlined condition. So we already know this is not going to be a function. Finally, every element that is being mapped is mapped only once. Well, this is true because 1 only appears once here and 1 only goes to one element in our B. So this is not a function because it breaks our second condition, because we are not mapping everything in our domain to something in our codomain. So let's quickly draw the set so you can better see why. So I've drawn our two sets A and B. Now let's draw our function. So our function says 1 maps to 2. Well, there we go. That's our whole function. Is it a subset of A cross B? Well, yes, there's no arrows that would need to leave any of these subsets. They would all stay within the 2. So yes. Does every element in A have an arrow leaving it? Does every element map onto something in our codomain? And the answer is no, because if you look at these elements here, 2, 3, and 4, they're lonely. They're not being led or paired with something on the right-hand side. They're not, so it breaks that second condition. Is there exactly one arrow leading from the element that is being mapped? And that's true. So there's only one arrow leading the 1. So it kind of does follow the second rule, but because it breaks the first rule, this is not a function.